Welcome to The Explainer. Today, we're putting on our detective hats to solve a real, everyday mystery. If you've ever tossed a bath bomb into a tub, you've seen it. That spectacular, almost violent fizzing and bubbling. But as scientific detectives, we've got to look past those pretty colors and ask a really fundamental question about what's actually happening to the matter in that tub. Today, we're going to figure out exactly where the gas in a bath bomb actually comes from.
Okay, let's dive right in. When you drop a completely dry, solid bath bomb into water, it almost immediately starts fizzing like crazy, releasing just tons of gas bubbles. But where is all that gas originating? The gas wasn't just floating around your bathroom waiting to jump in, and the water certainly wasn't bubbling on its own. It's a super fascinating puzzle, and it really forces us to test our basic assumptions about how matter behaves.
To get this investigation going, we've basically got two main suspects in our lineup. Suspect number one, the gas is already trapped inside tiny microscopic pockets in the dry bath bomb, just waiting to escape when the water breaks it apart. Or suspect number two, the gas comes from a physical or chemical transformation of the matter that was already there. So, to figure out which one is the real culprit, we need some cold, hard evidence.
To crack this case, we're going to lean on a really crucial model idea: the closed system. Basically, a closed system is a physical setup where absolutely zero matter can get in and zero matter can get out. And since all matter has mass, if nothing enters or leaves, the total mass of the system has to stay exactly the same. This one, simple, profound rule is going to be our best tool for interrogating our two suspects.
All right, so we set up our first interrogation, which we like to call the crush test. We take some dry bath bombs, pop them into a Ziploc bag, squeeze out as much air as we possibly can, and seal it up tight. Boom, we have our closed system. We toss it on a super sensitive digital scale to get our starting mass. And then, for the fun part, we take a heavy object and just completely pulverize those dry bath bombs inside the sealed bag. Finally, we weigh the whole thing one more time.
Now, I want you to think about this for a second. If suspect one is guilty, meaning if that gas was literally already trapped inside those dry cubes, what should physically happen to our sealed bag when we smash them to pieces? Well, gas is matter, right? And gas takes up space. So if we're breaking open all these hidden pockets of gas inside a flexible sealed bag, we should definitely see that bag inflate like a balloon.
But the results were instant and honestly undeniable. The closed bag didn't inflate at all. It just laid there completely flat. Even after the bath bombs were totally pulverized into dust, there was literally zero visible expansion whatsoever.
But hey, we don't just trust our eyes. We check the numbers. The mass of the closed system before crushing was exactly identical to the mass after crushing. Nothing got in, nothing got out. But we took it a step further. We unsealed the bag, turning it into an open system. If there was any trapped gas that had just been released, it would escape into the room and the mass on the scale would drop. But nope, even after opening the bag, the mass didn't change one bit.
So, the evidence is pretty darn conclusive. Suspect one is totally busted. Based on that flat bag and the unchanging mass, we can safely conclude the gas is definitely not trapped inside the dry bath bomb itself. Claim one, totally thrown out. So, here's the real kicker. If the gas wasn't hiding in tiny pockets inside the dry bath bomb, where on earth did it come from when it hit the water? Because we know the gas is real, we've all seen the bubbles. This pivots our entire investigation away from what it isn't and forces us to look at what it is. We need to look hard at suspect two. The idea that the gas is created by a change to the matter that was already present.
And that brings us to our next experiment, the bottle test. To test suspect two, we've got to upgrade our gear. We need a rigid, closed system that can handle a buildup of gas pressure without stretching out. So we swapped the bag for a sturdy plastic soda bottle with a really tight screw-on cap. Add in our dry bath bombs, some water, a little plastic test tube, and our digital scale, and we are ready to go.
Setting this up takes a bit of precision. First, we carefully add exactly 100 grams of water to the bottle. But, and this is key, we cannot let the bath bombs touch the water yet. So we put the dry bombs into that little plastic test tube and suspend it inside the bottle. Screw the cap on as tight as it goes. Now we have a perfectly separated, sealed, closed system. We record the total starting mass, and then we just tip the bottle over. The water on the bath bombs mix, the explosive fizzing starts, and once it finally stops, we weigh the whole closed system again.
The data from this test? Absolute smoking gun. Before mixing the bath bombs and the water, we had our specific starting mass. After tilting the bottle and letting it fizz like crazy, the mass was absolutely identical. The scale literally did not budge.
And this observation leads to a really profound scientific realization. If the mass of that closed system stays exactly the same before and after all that fizzing, it means no brand new matter was just magically created out of thin air. The gas now pressing against the inside of that bottle, it had to come from the ingredients, the actual matter, that was already sealed inside the bottle from the very start.
But we still need to prove that this gas is actually taking up mass inside the bottle. So watch what happens next. We take our closed system, we carefully unscrew the cap to make it an open system, and immediately, shh, you can hear the pressurized gas escaping into the room. We put the open bottle and the cap right back on the scale, and sure enough, the mass decreased.
And we're not talking about some tiny, unnoticeable error on the scale. The digital readout showed a significant, completely measurable drop in mass, more than 0.1 grams. Now, 0.1 grams might sound small to us, but in the world of chemistry, that represents a massive, massive amount of physical gas atoms leaving our system when we open that cap.
So let's piece all these clues together. We know gases are a physical state of matter. Because gases are matter, they have mass and they take up space. So when we opened that bottle and heard that hiss, the escaping gas took its mass right out the door with it. That perfectly explains why the open system's total mass dropped. It proves, without a doubt, that the escaping gas was made of the matter we started with in the bottle.
So, let's explicitly lay out our final verdict for this explainer. First, as we definitively proved with the crush test, the gas we observed from the bath bomb does not come from any gas that was originally trapped in the bath bomb itself.
Instead, just like our bottle test showed us, the gas we observed when the bath bomb was placed in water comes from some change to the matter that was already there to begin with. It is a literal chemical transformation of the solid and liquid ingredients we started with.
We've completely ruled out trapped air, and we know for a fact the matter we started with physically transformed to create this new gas. Which leaves us with a fascinating question for you to ponder next time you take a bath. If the matter changed to create this gas, what exact chemical change just took place in your bathtub? It's a brilliant puzzle about interacting ingredients, and I highly encourage you to keep exploring it. Thanks for joining me on this explainer, and keep asking questions about the matter all around you.